My name is Murali Gandluru, and I'm the Vice President of Product Management at Arrcus. I have the CTO and co-founder, Keyur Patel, co-founder of Arrcus, today as well. And together, we're going to talk about, over the next 90 minutes, talk about how the networking industry is being disrupted from the first principles. You know, when I look at the inflection points that the networking industry has gone through the past few years, and over the 16 years of networking experience that I've had prior to this at Cisco Systems, I've been part of a few. One thing we've noticed is that there's been a wave, of course, of SDN, followed by now some trends around SD-WAN and so on. But fundamentally, all of those inflection points have operated around network silos. And those silos, it typically point towards a pin in the network or a place in the network, a data center, the edge. All of them still operate within those confines. But what's happening with digital transformation, which is a very abused word right now, overused word, is that fundamentally there's the rapidity of changes that are required from the infrastructure has accelerated beyond compare. And effectively, network transformation is a crucial part of this transformation. And so today, what we're going to show is that the network transformation requires, from the first principles, that the solutions that are provided are agile, cross boundaries prior that were solved by independent solutions or different solutions from the big vendors, and essentially show that it is possible to build a networking solution that transforms across all of these environments. Arrcus is the modern OEM that democratizes networking by providing best-in-class software with a flexible consumption model at the lowest TCO. And that's what we're going to focus on, how we do that. A quick read about the company. We are a well-funded venture capital VC firm, backed firm, and we recently announced our Series B. We've raised about $49 million by industry as well as leaders from tier one venture capital firms. The names that are right there, Lightspeed, General Catalyst, Clear Ventures. We also are backed by an august audience of advisors who have tremendous amount of experience at some of the most product lines and business units at Cisco, Juniper, and other places. And the reason why we all came together was because, as I said, when we looked at some of the things that were done really well, they were always within the confines of certain silos. But what's happening is there is a need towards moving across these environments and provide a solution that is agile, elastic, and cognitive. So fundamentally, what I'm going to do today is go over the product's overview, followed by Keyur going over the architectural deep dive of what ArcOS, which is our flagship product, and ArcIQ, our analytics platform, are all about. And then we're going to show that switching and routing don't necessarily have to be independent silos through 4 demos. 3 of them are recorded, and I'll narrate through. And the last one is actually going to be a live demo. Arrcus, when Arrcus was founded, one of the key things that fundamentally was required was that this operating system has to be able to be deployed across all of the environments that I already mentioned a few times. One of the key things that was required was to start from the first principles. And when I say first principles, what it means is that instead of taking independent open source software and gluing them together and trying to solve specific problems, what was needed was to go back and build a team, first and foremost, that has many years of experience building this across some of the leading product lines, and try to take a clean slate and first principles approach to building that operating that can address all of these use cases. One of the things that's happened in the networking industry is that the topologies have simplified. We see spine leaf designs no longer just in the data center. We see them in the evolved packet cores. We see them at storefronts. We're seeing them at all kinds, at regional cloud locations. Every one of them are moving into spine leaf designs. We're moving away from proprietary layer 2 switching-centric environments to routing, dynamic and more agile routing-centric solutions from the data center all the way to the edge. So to do that, we started out by focusing on the network operating system. We also made sure that we have open standards APIs northbound, as well as provide a API-based framework towards a analytics platform. And I'll get into these two product lines as well. So the first product we launched was ArcOS last year when we came out of stealth. We announced the early evaluation of ArcIQ, and I'll touch upon that as well shortly. So the 4 big use cases we started looking at when we launched was the IP clause. That IP clause could be inside a data center, it could be at the edge. We looked at peering routers. Typically, when you hear peering routers or any sort of edge backbone use cases, you're thinking big honking routers that are many line cards filled, as well as expensive is the key thing that comes to mind. But that's because there's a lot of legacy proprietary feature set and capabilities that exist in those environments, which with the innovation that's been driven by the underlying silicon now brings the possibility of an agile software to run in these environments. Then there's also a new area of networking that's being tackled right now called open aggregated routing. Essentially, the ability to provide an innovative solution where you can stack a bunch of data plane instances and have your control plane sit outside and manage them independently. Finally, the ability to also run in a virtual or a cloud instance form factor to be able to address some of the cloud interconnect use cases. So effectively, what that meant was, from ArcOS perspective, build a network operating system from modern principles. Take a restart from the clean slate and build a composable microservices-based architecture, 64-bit user space, and try to and focus on building a best-in-class protocol support. That's crucial because our internet, our backbone, even our data centers now effectively run, for example, BGP across the board. What has happened is BGP as a control plane has standardized first with the spine leaf designs inside the data center, many years, for the last 15, 20 years in the backbone and at the edge as well. So the control plane-wise, scale out and scale up are key elements. So build that best-in-class protocol from first principles, and then always focus on open standards. Because now what's happening is by focusing on open standards, effectively we are able to integrate into existing systems and provide easy, seamless integration into the manageability and operations environments. And then when we launched, we made sure that we supported both a switching chipset as well as a routing chipset. Broadcom, being the leading merchant silicon vendor, has both classes, families of network silicon, and the ability to support both of them was not there prior to this. Virtual machine container support. We have a software called ArcRR, which is a route reflector that can actually be in a container form factor. Similarly, we have other such use cases that you could build because the software is composable. So no longer do you need to have a issue of customers that face constraints due to code bloat, poor quality, that you're forced to take software that you're actually not using. So effectively, that composability brings that ability into the picture. Open models, open config, Yang. Open config is standardizing across the industry. So all kinds of frameworks that integrate with this system, whether it's Ansible-based framework, which we will show in one of our demos, whether it's a controller that integrates into the fabric, data center, or outside, all use open standard mechanisms. So you don't have to deal with proprietary controller device hooks anymore. So what that means is that effectively we are able to build out from an architectural perspective as well as from an operational perspective, go focus on a scale-up, scale-out control plane, build a data plane that spans all the way from 1 gig through 400 gig, be able to deploy in the variety of form factors that I talked about, and use open standard mechanisms to integrate into these environments. That's why we were able to, our customers are able to deploy us in each of these environments.
I'm curious about your route reflector solution. Are you using that for full table route reflectors? Have you deployed it in that instance?
Yes.
And what do you guys see as far as the number of tables that you can get into there? If I wanted to have some kind of an exchange or peering fabric, how well does that scale against? I'm assuming that runs on an x86 platform, or does that run on an ONI white box platform? The route reflector specifically.
So the route reflector runs in a container form factor on an x86 server. And essentially, we are able to scale, and we will show that as a part of a demo. We are able to scale over 100 million paths. So effectively, what that means is you're able to take many times, obviously, the internet routing table and equal cost multipath it across multiple peers. And so essentially, to your point, the route reflector is becoming increasingly a control point or a policy point from a networking control plane point of view. And essentially, scale there is a very key element. Scale up and scale out, having multiple instances. So that's an indicator. And we have a demo that will show that later.
Okay, cool.
Would you like to add anything else?
I'll cover that.
Okay. And Keyur will talk a bit more about it in his section as well. Also, the other thing is ArcOS itself can actually, on a white box hardware, it can actually scale up to a full internet routing table. So that's the peering router use case, a physical router use case as well.
And what chip are you guys, what boards are you guys putting that on? Which type of OEMs are you using for that?
So in this particular...
For the full table example.
Yeah, so we have support for the highest end from Broadcom, which is the Jericho 2 that was announced a few months ago. But the architecture itself has been built to support any underlying hardware, and I'll get into that in a few minutes. Actually, Keyur will talk a lot more about how we were able to achieve that. But the first one we are supporting is the Jericho 2. In fact, prior to this generation of Broadcom chipsets from with the Jericho 2 family, effectively there wasn't an alternative to the traditional incumbents in terms of the feature set that was required at this point in the network. In the backbone and the edge. So now we actually have the ability to have high density 100 gig, be able to do things like S-flow line rate, be able to then, on the other side, be able to figure out the malicious flows and stop them and things like that. That was not possible other than going back to a traditional incumbent. So when we launched last year in July, August timeframe, essentially what we did was we supported both the Trident 3 and the XGS family. In the merchant silicon world, on the data center side, the XGS family has been very popular. It's been used for a number of use cases, specifically around spine, leaf designs, and so on over the years. And then the DNX family as well from Broadcom. I'm giving that specific example. Broadcom enabled the ability to do high density routing, but not at the scale that we get now with Jericho 2. So when we launched, effectively we supported both of these chipsets. It's equivalent to, that gives you an idea about the fact that the abstraction layer or that you communicate down is independent of the chipset that's there, and because they're two independent families pretty much. And so by doing that, we were able to be deployed in the routing use case that you were talking about, as well as in the data center as a leaf or a spine. Then earlier this year in January, we announced the support for a high density 100 gig, 400 gig solution, essentially bringing 400 gig to open networking. And in fact, a little bit of marketing there. We have been the first open networking, independent network operating system to support all of these at every stage, which is whether it's the first to support the XGS platform, DNX platform combined together, and 400 gig Tomahawk 3, which allows now to be able to fan out and save operators to save costs by actually building a high-density 100 gig based data center fabric. Then in July, we announced, of course, the routing solutions that I just talked about, which is the highest end from Broadcom, the Jericho 2. Because of that, we were able to, because we were able to use this particular spread, we have the ability essentially to have a single software, common architecture across all of these environments. And the advantage of that is that when operators, our customers tell us the advantage for them is that they're able to use a single operationalized environment, whether it is from provisioning point of view or managing across the data center and the edge and the backbone as well. We have a wide choice of platforms supported, 1 gig through 400 gig from all of our the leading ODM vendors out there. Right from a out-of-band, this addresses use cases right from the out-of-band management switch all the way up to the highest end of the routing family. When we announced the Jericho 2 support, we wanted to highlight a key point. The architecture itself, and Keyur will go into this a lot more, the architecture itself was built to support not just a small fixed router that would sit at a POP or an edge peering location or a EPC or a storefront, but also the ability to support a high-density fixed platform and also the ability to go and go beyond that. Because what happens is, so for example, in this particular case, the routing family supports, with the Jericho 2, you're able to go up to 48 ports of 100 gig. You can go with a high density fix, you can go up to 96 ports of 100 gig. So effectively, now that we were able to support these form factors, this clearly shows the direction that the architecture can actually go into these environments. The reason those environments are important is because there are certain use cases, and you may have seen some announcement earlier this week from AT&T saying that they're donating certain the specifications of an open aggregated routing solution to OCP. The ability to support that in software architecture is key. And that has been already validated in ArcOS. So now what you can do is effectively, instead of having to be constrained by a modular chassis in certain use cases, the physical dimensions, you now have the ability to go beyond that. Because as we all have seen, some multi-chassis solutions that existed are cost ineffective and essentially cause a lot of, both from a CapEx as well as from an operations perspective. So the ability to go beyond that is from an architecture is critical. And so that's why that new trend of being able to provide an open aggregated routing solution is key. So ArcOS has been architected for supporting this full spectrum. And yes, it's a single architecture across all of these environments. One of the key things I want to point out also is that when I say that we can be deployed in any of these environments, I just want to provide a contrast. When you look at a data center, typical data center, there are many use cases. There may be a case where a traditional shallow buffer environment where you have Trident 3s and your Leaf and Tomahawks in your spine, and you have some traditional incumbent as your high density router typically. Now, that now can be all addressed with one software. In a traditional incumbent or one of the vendors that you have today, you would have had to provide a solution, a different operating system for each or at least some of these layers. So that's an inconsistency in provisioning or managing and so on. It increases cost. So now with the ability of the merchant silicon to actually span all of these environments, there is a significant amount of push towards having common software architectures across. And by going with open standards approach across all of these environments, we are able to provide the speed of deployment as well, improve that as well. So all of these use cases, what you will see is whether that's for the edge computing environments, whether that's for the data center or for peering environments, you are able to now have solutions that can be a single thread, agile, elastic across the full spectrum. The other thing we announced a few months ago in March was we built an IP clause last July, right? Traditional IP routing-based forwarding scheme. Then we had customers come to us and tell us, hey, this is great. We would like to use your standards-based approach to build an EVPN multi-tenant fabric. So the reason multi-tenancy is important, obviously, is because you want to be able to have many, many customers or departments, in case of enterprises, co-located on the same infrastructure, maybe for private cloud environments, or even for the ability to connect multiple pods of compute together. And so essentially what we announced was the support for BGP EVPN over VXLAN and standards-based interoperable with all of the leading vendors out there. That provides us now the ability to do both layer 2 extensions, that is workloads, being able to extend workloads across pods or even across racks, the ability to support routed environments all the way down to the top of rack for the overlay. And we added, as with everything else, we've added a sort of a differentiator as well in terms of our EVPN solution. What we did was in a typical multi-tenant fabric, what you have is you have an underlay that's a protocol, typically ISIS or OSPF, and you have the overlay, which is BGP EVPN. So now you have operators that need to learn both of these environments. So essentially, with the BGP LSVR, what we've done, which is a standards-based approach, what we've done is we've reduced that from 2 protocols to 1. And essentially, from an operational perspective, it allows for simple deployment and manageability. And in addition to that, as I'll touch upon in the next slide, it's also a lot more cost-effective in terms of how you're using your CPU resources and so on. Finally, open integration, as I said, with other vendors, as well as open integrations northbound. We actually have a demo on our website which shows integration into an ODL-based controller. So it's very seamless. We also have a provisioning frameworks integration with Ansible to show that you can build EVPN fabrics scalable across all of these environments. We will not be showing that demo. If you have time, we can show it probably, but it's there on our website. But effectively, this is also customer-driven. Customers want open standards, scale, and simplicity. So effectively focusing on these 3 things: simple to operate and manage, scalable, scale out and scale up, and seamless integration in these environments.
Your slide there talks about your APIs and northbound APIs and stuff like that. Do they have the same access as the CLI? Is the CLI based on the API, or how did those 2 meld together?
Yes, so the underlying backend, the config data store that we have is common across all of these environments. So you essentially have a standards-based model that's projected out from the operating system. There's an equivalent CLI approach as well for people who want to continue using the CLIs, and it's very familiar CLIs, as you will see in the demos as well. And so, yes, the short answer is...
So full access.
Yes, full access, everything.
Full access to all commands and all features, no matter how you're programming them.
Absolutely, right?
Yeah, it's a model-driven orchestration system, uses OpenConfig as the models for it, and the CLI is also modeled after OpenConfig as well as the REST and netconf. So no translations, just native OpenConfig.
Thank you.
And the other thing I want to point out is that you have deep, not just access in terms of provisioning, but also nowadays one of the key things that's important is real-time visibility. What we have, for example, with the EVPN fabric is ability to have per tenant visibility with real-time streaming and a correlation with the kind of traffic patterns as well, the backend.
I've got a question for you on LSVR. Is that, so you're using that to get rid of the IGP inside the data center fabric for leaf spine. Is that is that a requirement? Is that how you have to deploy, or is that just an option you have to deploy? So if you wanted a traditional IGP underneath with BGP on top and EVPN as an address family, that's still an option.
That's great. That's a great question. In fact, we support both as an option because we certainly understand that there are a lot of deployments today that use a traditional IGP, ISIS or SPF. What we do say is that when we use LSVR, what you will have is the ability to build, first of all, standard is on one one protocol, right? Simplifies the operator's life. Second is faster scale and convergence in terms of how much time it takes to build out this fabric, any changes, the underlay, any changes there, and so on. And then also, as we were just talking about the open aggregated routing designs, the same model applies inside data centers or other parts of the network as well, where you essentially have the ability to centralize your underlay control plane so that you don't end up using a lot of resources on each of these instances and wasting CPU cycles there. So it's faster scale and convergence.
Do you see any scale challenges with that? Because I know a lot of large data center fabrics will run like ISIS, and they'll run BGP at the edges of where they're building the data center fabric. And so, I've not deployed LSVR, but I'm curious if you see scale challenges in collapsing the IGP and BGP into the same protocol.
Go ahead, Keith.
One of the things that we are after is when you look at dense topologies, and particularly with the advent of TH3s of the world, where you have a much more dense fan out, if you will, at 100 gigs, you're going to see your BGP sessions grow. In case of an IGP, which is deployed as an underlay, you're going to see a lot of noise from just from the IGP distribution that comes out. LSVR is something you should think of it in a nutshell as a SPF. So in that case, it's very similar to IGP, but it's a point-to-point session, which leverages all the advantages of point-to-point sessions that BGP has. And the biggest advantage of that is you eliminate all the redundant traffic, control plane traffic that goes in your network. At the same time, you leverage all the CPUs that are made available to you to do distributed computing, also known as SPF, right?
Okay.
So in short, the answer to your question is scale is actually one of the advantages of this approach, because as we all know, data center fabrics from at least in some of the hyperscalers and so on have all standardized around BGP, right, for the underlay. So scale is actually something that's increasingly BGP is solving in different parts of the network. What LSVR solves uniquely is the point of getting a shortest path first approach to BGP, which was not originally that model. So you kind of combine both together, and so you get the best of both worlds. But we are not mandating that you have to use LSVR for the underlay. In fact, the demo that we show will be based on ISIS.
Okay.
To your point, so that should we do think that this approach simplifies, because a lot of the main thing that's going on right now is simplification of these layered cake protocol mechanisms across all of the networks, whether it's in the data center or outside. That's a big ask from customers.
Okay.
And it lends itself very well to a software-defined model where you can put a centralized policy model, just like you would with a route reflector and so on. This approach can be applicable now across multiple layers. Driving open standards. I think I've mentioned the word open a billion times already. So essentially, we are taking a leadership role in driving open standards in collaboration with pretty much all of the leading vendors out there. In over 50 plus, we have our Arrcus employees, and of course, led by Keyur. We are part of over 50 drafts or RFCs spanning the full routing networking spectrum. Once we built that operating system, one of the things that one of our customers asked was, it would be awesome if you're streaming all of these things out. I will have to build a platform, a software platform that actually consumes this and provides correlations. The raw data is not enough. So the key thing that these set of customers, actually is more than one, asked us was, I need real-time visibility. I need granular control for my network. I need to be able to make decisions, say, for example, I see malicious flows at this point of the network, shut this flow down or a bunch of flows down, and then be able to apply that to security. as a use case. And we'll touch upon a few of those examples. So fundamentally, ArcIQ, our analytics platform, was built out of this particular requirement from our customers. And we announced the early availability for evaluation from our customers in July, along with our high-density routing launch. So effectively, the key 3 areas that we focused on was providing deep insights into the network health. So the status of your switch or router, be able to tell whether you've hit certain thresholds in terms of temperature, fans not working, or you see things like a lot of error discards or counters not, a lot of insights into the device itself, the device health. We also wanted to provide real-time control plane visibility at scale. And when I say scale, I'm talking about internet scale, the full routing table scale. Be able to provide data plane information with the example that I gave earlier of counters and statistics of the interfaces and so on. So basically, once we got those data points out onto this analytics platform, then we were able to do interesting things. For example, we are able to track, for a data center, we are able to track workload mobility. And that's one use case we will show today. How, when a workload moves from one rack to another, especially in a containerized environments, containers, their lifetime is very short and they show up in different places, right? So effectively, the ability for the network domain to be able to view that mobility in real time is important. If I had to log into 100 racks in a data center topology to figure out what's gone where, it becomes complex. So the ability to provide that was an ask from one of our customers. The other example, which we won't show in a demo, but something that's extremely important in the internet today, in the internet working world, is route hijacking or malicious environments related to spoofing of routes. That causes a lot of business transactional loss, including the famous Bitcoin theft that happened earlier this year, I think earlier in this year, with one very common use case that shows up, which is route origin validation. Effectively, now you can actually tell whether a particular, say I'm peering with somebody else, if they advertise a route or a particular endpoint to me, claiming that they are the ones that have that route behind them, but in fact they've stolen that route, or by mistake or misconfiguration, it could be harmless. Then what would happen is it could take down services. I mean, we've seen those examples as well. So route origin validation is a key requirement now, especially as the number of points that are opening up to the internet from the edges has increased many fold. That's a capability that we have in ArcOS with ArcIQ as well.
How are you validating these routes?
So what we would do is there is a standards-based database, which is called the RPKI database. And essentially what we use is we take that and we compare with the routes actually on the, say, a bunch of routers, and then look at, see whether those are actually part of the official database of advertised, autonomous systems and routes that we are supposed to be learning from, etc. So effectively, when we do that validation check, then you can immediately tell that this is actually not supposed to be advertised from this AS, but from somebody else. So immediately, you can the alert is sent to the operator, and then they can take action on shutting it down. So that's sort of the workflow.
Yeah, and is there any lag time involved in that process? Like, say, would it disrupt business at all?
Yeah, so today, as it stands, there is actually business impact when people don't even know. First thing is to know that there has been such a advertisement of routes from a place which is not supposed to be the origin. And so essentially, there's significant amount of business disruption today. So the first step is to be able to alert that, hey, this is what has happened. Once that alerting process has begun, then it depends on how fast the operator can shut it down. And we provide mechanisms to shut it down as well, but we leave that ownership or the onus on the operator to decide whether they want to shut it down or not.
Okay.
So that delta of time is what we are significantly mitigating or reducing.
Okay, but the time to like ping the database, is it a significant amount of time or?
It's a tunable time that is used at the back end where the software connects to all the RIRs and downloads the certs at every regular interval. One thing that we do as part of the telemetry effort that Murali was talking about is we actually stream everything out, just not the SNMP counters, including BGP routes, paths, and attributes. And that's almost, it is actually anything in the control plane is a push-based mechanism rather than a poll. So if you see a BGP route change, we would stream it out. And from that perspective, there is no delay. It's almost instantaneous. And at the back end, it'll do the validation right as the route comes in.
Okay, so you're doing security validation and your end users don't even know what's going on. Awesome, thank you.
And ArcIQ is deployable as on a physical server or also on the cloud, AWS and Azure. So we have all kinds of use cases that we've gotten from customers. So it's flexible. So multi-cloud as well as on a server, physical x86. So finally, the point I want to leave you as I transition over to Keyur is ArcOS Anywhere effectively aligns the point that we have so far been treated to, for a variety of reasons, treated to a bunch of silos, data center, campus or enterprise, the backbone, the edge, all of them with different provisioning models, different APIs, a whole bunch of inconsistencies that has caused a lot of operational cost in addition to the CapEx cost. So now with the evolution of the merchant silicon to be able to address all of these use cases, we now have with ArcOS the ability to democratize any of these environments, all the way from the traditional data centers to the edge, and of course on the public cloud as well. With that, I'll hand over to Keyur.
Just one quick question.
Yeah.
Going back to your polling of the RIR databases, a lot of those, like for Arrcus or things like that, have limitations on how many times or how often they like you to poll them. Is there something that you're working on in terms of an independent setup where there can be multiple polls? Because I know Corey was talking about how quickly that happens, and
yes,
you mentioned something about how often you re-ask what's going on. And all I'm thinking of is like, okay, so if a lot of people are doing this, they're going to get a little irritated by it. So I mean, what kind of long-term plans do we have? Because it's a great idea. I'd love that part, but I'm just kind of thinking about how is that going to scale? How's that going to actually be operational? Just because it's not being done right now, so somebody somewhere is going to have to go, okay.
So right now, you're absolutely right. We are slowed down or delayed at the rate which RIR forces us to allow them to poll. The meta message through the application was, and one of the things we are trying to do is, for the networks, one option is to run this thing on the router and then use the RPKI to route a protocol and connect somewhere in the cloud or do this. One of the things we wanted to do it as part of a telemetry platform and give that to the operators so they have a single point or bunch of points, if you will, they can drop it into the POPs and monitor it. From that point onwards, as they operationalize it, the reactive rate with RIR will constantly depend on how fast the RIRs will allow us. But the software will fundamentally scale up, if you will, to an aggressive timers if you need it to be at that rate.
Well, okay, and that still makes it a RIR to carrier problem.
Yes.
Okay, has there, and maybe the answer is no, and that's fine. Has there been any thought possibly on your part for maintaining your own version of that, so you guys are polling once and then everybody else might be polling you?
We are looking at some of those efforts, but again, the mapping and the certs do reside at the RIRs. So, I mean, we could cache that, which is what we are doing. Right. But at the end of the day, we have to go to RIRs to see has there been any change.
Well, no, understand. But if I'm saying if you guys are the one place doing that, that's a whole lot different than 1,000 places trying to do that all at the same time.
Sure.
So yeah, that's just kind of what I was thinking of.
Sure.
Again, scaling
certainly, that scale aspect is something that's being worked in the open standards body.
Yeah.
This is an open standard approach as well. So I like the point that you're bringing up, and certainly the ability to cache on a more regular basis and address it locally will help scale. Agree.
And that is precisely what we are doing with the RPKI data right now.
Yeah.
So we do cache it at one point and then locally validate it. Yeah.
So Scott, just for clarification, RADB does that too, to break away from the individual routing registries. RADB is an independent routing registry, and they kind of help you offload if the RIR is being slow, because
Well,
they've got providers that will hit
absolutely.
both for route validation.
And I
so
think
that you're
about
not
each of the carriers doing that as well, keeping their
Yeah.
own RADB database. But I'm trying to find a way to more centralize that as opposed to the decentralized approach where
Yeah.
you get bad data propagating, as opposed to being able to find something and try to validate it at a much more concentrated level.
Right.
But I mean, it might fall into the ain't gonna happen now category.
No, but I think that's why independent routing registries are still valuable rather than just going
Yeah.
to the registry, because you have that, back check against the RIR.
Exactly. And we would punt the problem to something like that, and we would then connect and use that caching mechanism.
Yeah.